Hi everybody, welcome back. So in this last video for section 3.1, we're going to be going over this applied problem using our first derivative max and min tools. So let's read over this. So minimizing production costs. So power over Ethernet, PoE says systems pass electrical power and data safely on Ethernet cabling, and the function C of x equals 144 plus x squared over 180x relates the weekly costs in thousands of dollars to the company to the number x in hundreds of PoE systems it manufactures and sells each week. So part A is asking us to determine the number of systems a manufacturer must produce to minimize cost. So here's that keyword, minimize cost. We're trying to figure out how we can minimize the cost of these PoE systems, right? So the way to do that is what we've been doing so far for 3.1, which is finding our minimum value. So part one is same thing. We always want to find critical values. Okay, so we want to take the derivative of this function right here. Okay, so recall our tools of derivatives. We have this on the numerator, this on the denominator. We want to take the derivative. So the only way we can do that, or the tool we learned how to do this, is using the quotient rule. So recall, right? Quotient rule is g times f prime minus f times g prime all over g squared. So what we got to do is take the derivative of this. So what we would do here is, pick our f, pick our g. F is usually on top, g is on the bottom. So then it's just a matter of finding each of these f and g primes. So we'll have f equals 144 plus x squared, and f prime is going to be just 2x. And g is 180x, so that means g prime is just 180. All right, so that means we could set up the derivative to be c prime of x is using our quotient rule here, which would be g, which is 180x times f prime, which is 2x, minus f, which is 144 plus x squared, times g prime, which is 180, all over 180x squared. All right, so let's go ahead and start simplifying this out a bit. So if I multiply 180x times 2x, I should end up with 360x squared. All right, and if I distribute in this 180, I should end up with 144 times 180 is 225,920 minus 180x squared all over, I'll just leave it like 180x squared. All right, so I have a couple like terms here of 380, 360x squared and negative 180x squared. I could combine those into 180x squared minus 25920 all over 180x squared. So essentially, this is my derivative, right? So remember for critical values, right? We have to set it equal to 0. So I need to set this whole thing equal to 0, but I only need to set the numerator, meaning the top, because in a real world sense, it doesn't matter where a function is undefined. We're talking about actual Ethernet cables and costs in thousands of dollars. We don't have to focus on whatever the bottom makes is undefined. So all we need to do is set the top equal to 0 and solve for it. So what we'll have here is 180x squared minus 25920 equals 0. So I'm going to move this guy to the right. So I'll end up with 180x squared equals 25920. If I divide 180 to both sides, I'll end up with x squared equals 144. And this works out really well because when I take the square root of this, I'll end up with x equals plus or minus 12. So x equals 12 and negative 12, but we are in a real world situation where we're talking about cables and cost, right? Doesn't make sense to have negative 12 cables, right? Can't have negative PoE systems. So what I'm going to do is just cross this out and say can't have negative PoE systems in real life, right? So really, our critical value is just x equals 12. Okay, so we have x equals 12. And so the way to really state if this is a minimum or not is checking out the number line, right? That's the best way to do it using that first derivative test. So we can probably fit this on the page still, but for the sake of note taking, I'm going to add a page. So step 2 would be a number line. All right, so what I'm going to do is create a number line, right, just like we did before. Luckily, I'm only checking out 1 point, so it won't be too much work to do. So what I'm checking out 12. Right, I'm checking out 12, and I'm checking out numbers to the left and right of 12. So you could pick anything you want. You can pick, um, 1, you can pick 12. I guess I'll pick just numbers a little more immediately around it. So something like 10 and something like 14. All right, and so test point. So I'm testing out these points. So let's go out to the side and actually plug these guys into the function. So I'm going to plug it into the original function, right? I'm sorry, the derivative, which is this guy right here. So I'll copy that down here just for reference. So I'm plugging 10 and 14 into there. So let's go ahead and do that. C prime of 10 equals 10 squared. I'm sorry, 180 times 10 squared minus 25920 all over 180 times 10 squared. All right, so if you do all these calculations, you'll end up with something like negative 0.0024, right? But we're not worried about the actual numerical value. We're worried about if it's negative or positive. So this is negative, which means it's going down. So let me kind of come up here and draw an arrow going down. So likewise, let me plug in 14 into this. So C prime of 14. Same thing, 180 times 14 squared minus 25920 all over 180 times 14, whole thing squared. And if you do those calculations, what you'd end up with is like 0.001, which is positive, which means we are increasing. So all this put together means that we have a min here. So finding the critical value, right, through a lot of work is going to be 12, and then putting that on a number line using our first derivative test, right? First derivative test to see whether it's a min or not actually holds up because we're decreasing before, increasing after, so it is a min. So what I'll say here is I'll say answer. The number systems, the manufacturer must produce to minimize cost is 1,200 POE systems, right? Because we're talking about in hundreds of POE systems. All right, so that's how you do part A. Okay, so part B is provide a math argument to demonstrate that once the manufacturer produces the minimizing number of systems, the cost will only increase, right? That's because after 12, we showed that our derivative is greater than 0, which means that it's going to be increasing it's at a rate of increasing, so positive. So it'll just be increasing after that. So I guess I could write a statement for that as well. So part B, right? Since the cost is increasing, on the interval, I'll say 12 to infinity because we don't know exactly where it's stopping. Then after 12, the cost will only increase. Right? It's just increasing after 12. So the cost is increasing. That's our mathematical argument. But okay, so that's it for this question, right? We put everything together, but now it's in an applied problem and just putting some things together like quotient rule. But we're still using the same principles like critical values, number line, max or min, first derivative test. Okay, but that's it for this video. We'll see you next time. Thank you. Bye.